Okay, so say that we can start. So just a quick check to see that you can hear me. So you can hear me and you can read about someone asking for coffee. Actually, you had 5 minutes to prepare coffee, right? From 11:30 to 11:35. Well, you can prepare coffee anyway, but we start chit-chatting now. Okay, so let's see what we have to do today. So we will do some exercises from the exercise sheet from lectures 3 and 4. Okay, so what we do now is to deal with LAG, ex3-4. So this is what we want to do. And so we have to cover several topics. So let's start by some orthogonal projection business. So I'd like to do what is called T.1, which asks me to find a line on the plane. So say find a line. Or maybe we use something slightly different here. So let's say we write it in black so we can distinguish what we are going to do. Okay, so this is 2.1. And we want to find a line on the plane alpha x plus y plus z equal 1. That's the first thing. And if possible, find a line on alpha passing through the point P of coordinates 1, 0, 0. So there are two things that we want to do here. The first thing is to find a line on this plane here. The second thing is to find a line on this plane going through these precise point. So this is a two question exercise, right? And we have to go through this by finding first any line on plane alpha, and then finding a line doing something that we would like the line to do. Okay, so let's say I give you a couple of minutes and I wait for possible answers from you about these two questions. So the first one, the orange one, is very simple. Just find any line on plane alpha. And I can do that immediately, right? Just by drawing it. Here it is, line L. Well, but that's not enough, right? Can you find equations for this line? So either Cartesian or parametric. So let's see how you deal with this. Once that's done, you have to do the next one. So you have alpha, and then there is some point P somewhere, and you want to know, can I find a line going through P and lying on alpha? Okay, so say 2 minutes from now to do this, and let's see what you can do. Yes, Giancarlos Ordone Herrera said, well, any line orthogonal to n equal 1, 1, 1. Well, why exactly that vector? Well, because Juan Carlos basically said, well, the vector 1, 1, 1 in lazy notation is the normal vector of the plane. So it says any line orthogonal to that, but probably is not completely true, right? Because if I picked, for example, this line here, well, say like this, that would not be what we want, but this is a little bit messy. So let's say I take all of this picture and I put it here. And what I want to note is that any line orthogonal to n alpha is probably a little bit too much. Because, for example, a line like this would be orthogonal to n alpha, but it is not lying on n alpha, right? So that's a good starting point, but we need to do something more. So just any line orthogonal is not enough because it could be far away from the plane. So we have to do more. Okay, so let's see when someone can come up with an explicit line doing what we want. Camilla Tetti, I'm afraid that all the notes for last week should be there. If not, it is a mistake because I upload them on the weekend. So they should be already there. Yeah. So I will double check, but please double check too. Yeah, if you're referring to the PDF file, should be there. But you know, it's also possible to make a mistake. Okay, so minutes passed. Let's see together how we can find this line on the plane. Okay, so there is one easy way, which is the following. I just take L to be alpha intersect beta, beta not parallel to alpha, right? So any choice of a plane not parallel to alpha will give me a line lying on plane alpha through intersection. So just take any plane beta not parallel to alpha. Can you suggest to me a plane parallel to alpha? Well, 8 September 2021 is still to come, so it's very interesting. So I think there is something wrong in this. Okay, so Alireza suggests for beta, x plus y plus z equal 2. Is this a good choice for beta? Or someone else suggests 3. But do you think it is a really good choice for beta? Or maybe it is not? Is this plane not orthogonal? Sorry, not parallel to alpha? Yes, the normal vector is the same, so they are parallel to alpha. So this is not good, because these would give a situation like this. This is alpha, this is beta. When you intersect it, what do you get? The empty set. So this beta you suggest is not working because it is parallel to alpha, not working. However, someone else suggests a plane which is like 2x plus 2i plus 2z. Still, it is very parallel to beta, to alpha. So this is not good. This is not good. Okay, finally, we got a plane which is okay. Kusha Eskandari says x equals 0, y equals 0, z equals 0, which is a point. So that's not a plane. Absolutely not. And then finally, someone came with the right idea. What do you have to do? You have to change the normal vector. Any way you change it is going to be fine. So any plane beta, for example, the one someone suggested, 2x plus 3y plus 5z equal whatever number you want, this is going to be okay. Meaning it is going to give me a situation in which alpha and beta, well, let's make a different picture. So this is alpha, this is beta. They actually intersect in a line L as required. So any plane not parallel to alpha will work, okay? Good. Then Greta Galletto says, D shouldn't be still 1. Why? There is no reason for that. What you need to do is to change any one of the 3 numbers you see here. To lose parallelism, you have to choose a new normal vector, which must be not proportional to 1, 1, 1. So you have just to make anything which is not proportional to 1, 1, 1, and it will work. D is completely not influent in this situation. Changing D moves a plane parallel to itself. Okay, so in this way, we produced one line L going through, lying on alpha. So for example, x plus y plus z equal 1, and then I use your suggestion, 2x plus 3y plus 5z equals 6. This is okay. This is a line lying on alpha, exactly as we want. So I hope this is clear. However, you can do it in a different way, basically using the suggestion that someone gave to us about the normal vector. So what can you do also? Well, you can do something also in this fashion, say. What can you do? Well, you can take plane alpha, then I take a point Q on plane alpha, then I choose a direction vector P, and I will produce a line. So the line V equal, say, OQ plus T times P, okay? That would be a new line. But what is the condition on P in such a way the line defined in this way lies on alpha? So if and only if, what happens to P? Can you tell me what should happen to P if we want the line produced in that way to be a line of plane alpha? Exactly, Paolo Lovera has the correct idea. Yes. Whatever I do, I have to get something orthogonal to n alpha. So this is the condition I have to put here. P dot product n alpha must be equals 0. Now, well, let's remember what is n alpha. It is I plus j plus k, right? So can you produce a vector p which is orthogonal to n alpha? Can you give me one? Of course, there are many, right? But can you give me one of these vectors? Yeah, Pascal Riaki suggests to say, well, I pick something like minus I plus j. And this is okay. This is working. Of course, you can produce many of these vectors, right? So how to find P? Here is the question. Well, what you need to do is to say, well, P is what I want to find. So AI plus BJ plus CK. And then I go and compute P dot n alpha, which I hope you see is A plus B plus C. And this is equal 0. So how do you find your vector P? You solve for A, B, and C. That's the typical situation. I want to find an unknown vector. I give unknown coefficients to the components. Then I write down some equation. In this case, here is the equation, only one linear equation. There are many, many solutions. So all possible vector P that I can pick are simply of the kind AI, BJ, and then what is going to be C. So what is the coefficient of K going to be? Can you tell me? Sorry, the coefficient of K. What is the coefficient of K going to be? Exactly. You solve it, so it is minus A minus B. So, for example, the one suggested it by, who was there? Paolo Lovera, maybe the first one suggesting something, I don't remember. No, Sofia Karnauk, maybe the first one. She basically picked A equal minus 1, B equal 1. But any other choice will do, okay? So now we write down the parametric form of the line. So what we got here is Cartesian equations. Remember, not only one, but there are two. So equations. And now we write down parametric equations for a line L, which is coming from this description, which will make our work. Also note, this is not the same line L we found before. So let me call it, say, line L prime. It's not the same line L we found before. It's another one. And to do that, we also need, if you remember, a point Q. So I have P, my vector minus I plus J. Now I need Q. I need Q on the plane alpha. Can you give me a point Q on the plane alpha that I can use to write down the parametric form of the line? Yep, 1, 0, 0, or any point such that the sum of the coordinate exactly, Giancarlo Sordones Herrera, such that the coordinates satisfy the equation of the plane. So 1, 0, 0 is fine, but anything which have sum equal 1 is going to work. Okay, so This is going to be v equal to what? 1, 0, 0 plus t times minus 1, 1, 0. And as I told you, very often people will call this x, y, z because this is the vector O r are any point on the line. Okay, so we have always our situation in which somewhere I have the coordinate system. And remember, this is what we often call vector v0 or OQ. And this is what we call vector v, or in this case, vector OR. So these parametric equations, as often written also in system format. So as x equal minus t plus 1, y equal t plus 0, z equal, well, it is just 0. So this second 0 here is not needed. And this is what we got, okay? Okay, how do you check that line L prime lies on plane alpha? How do you check this? What do you do? Well, if you put t equals 0, you will just get back this point here, right? So this is what you get for t equals 0. Well, that's not very interesting because you just check that the line goes through Q, which of course it does, right? Okay, yes, there are two ways to answer this. Substitute, which means what? It means take the equation of the plane x plus y plus z equal 1, and instead of x, y, and z, you place what we have here. So minus t plus 1, t and 0, and you get minus t plus 1 plus t plus 0, and you must get an identity. So something which is true for all values of t. And this is okay because these two cancel out and you get 1 equal 1, which is fine. So substituting is okay. Or, so I say substitute in alpha, or I would say substitute values of t. But it is basically the same thing. So for t equals 0, I obtain point Q, which is in alpha. For t equal 1, I will obtain a new point, call it z. If this point is on alpha again, then the unique line joining the 2 points will be on alpha, right? So you have just to check if this point is on alpha. If it does, then since your line L prime is the unique line joining the 2 points, then it must be contained in alpha 2. So what you do here, you compute the components of z by substitute t equal 1 in this expression. So you see you get 1 minus 1, 0, 0 plus 1, 1, 0 plus 0. So I got 0, 1, 0. And so even in this situation, we get the same answer. It is true. The line lies on plane alpha. Okay, so this is as far as we want to discuss this about finding any line we want on the plane. So let's see in the chat. There are a couple of questions. Francesca Zapulla says, no, she was suggesting something. Tommaso Ferren says, I didn't get the parametric equation of L. The parametric equation of L comes from what we studied in the lecture. So let me go here. So this is the parametric equation of a line, right? So it is given by some fixed vector and a moving part, which requires a direction vector. So first we need to find the direction vector and then any point on the plane. So the point that some of you suggested was this point here, that it was a suggestion people made. And then we had to produce P first. How P is produced? By the condition that P forms a 90-degree angle with the normal vector. That's the only condition we have, okay? And once you have that, you just substitute in the equation we studied last lecture or say this week, okay? Good, that's fine. I hope it is clear. If there are not further questions, what we should do is to go back and see that we did the first part, you see? We did the first part, we found a line on alpha, and we saw also how to find all of them, okay? And then now we have to do the second part. So people who understood what we did up to now, please start finding a line going through P1000. Then I look in the chat. Christian Fiorina says, I didn't get how we define vector P. Well, vector P is just any vector parallel to the plane. How do you find the vectors parallel to the plane? They must be orthogonal to the normal vector. That's the property of the normal vector. So the normal vector is here, as we studied it. Being orthogonal means zero dot product. So you look for any vector P satisfying this equation. You compute, you get that A plus B plus C must be 0. You solve it. The general form is here. Then you give any value you want to A and B. Or, as some of you did, you just find by looking a vector orthogonal to this one. And this is something you can do kind of easily when you start playing with the dot product. So the task we have to do now is this. So let's carry it down with us. So we want to find, if possible, a line on the plane doing something special, passing through the point 100, okay? And I hope you agree with me that if the point is out of the plane, then the answer will be L does not exist, right? If the point is on the plane, well, then you can find L. So the first check is, well, is the point outside or on the plane? So which of the situation are we actually into? The line we found goes through point 100 and 010. Yeah, by good luck, this is what we managed to do. Yeah. But, you know, you have to realize it. Okay, so what is the fact? The fact is that we are in this situation and L prime found above works. You cannot find the line if the point is outside the plane, okay? What Giancarlo Herrera is suggested is that there is a general procedure for doing this, right? Someone say that P0, P dot n should be 0, but that's not completely clear to me what you mean. Seved Mostafa Severi, so maybe try to explain it a little bit clearer, in a clearer way, sorry. So what do you do in general if you have, say, any points, say a point A here, and you want to find a line, call it R containing A, R containing alpha. So how do you find it? What's the general procedure? And the general procedure is probably something you can describe to me kind of easily, right? So suppose this is point 1/3, 1/3, 1/3. How do you find the line? So I think that someone already said it, but let's see. The easiest way is to find it in parametric form. So how do we go and find the line in parametric form? I don't see what you mean by P0P. That's the part I don't understand, Seyedi. When you write P0P dot n, that's the part I don't understand. P0P. P0P is what I don't really understand. You mean is another point on the plane, and then you want to make the vector P0 dot n equal 0. Yes, in some sense, that's a good idea. You compute a line going through 2 points on the plane. So what you are saying is, well, if I want to find this line R, I can just say I pick any other point on the plane I want, and then I just join these 2, point A and the new cross point, and that will be a line on the plane. Yeah, you're perfectly fine. You can just find any other point of the plane and join them. Yep, now I understand. Perfect. Yep, that's a very nice idea. Why 1/3? Because I pick a point and I ask you to find a line going through that point inside the plane. Yeah, that's a possible exercise. You can pick the numbers you want as soon as the sum is 1, otherwise they are not on the plane, right? Okay, so how do you go and find this line? I guess that everyone knows how to do that. You look at the normal vector, which we know very well. You just need to find some P such that P dot n alpha is 0. And then you write down the parametric equation using the point A. Right? So how would it look like? X, Y, Z, right? Then there will be 1/3, 1/3, 1/3. This is the starting point. Imagine it like physics when you take t as time. This expression basically tells you that at time 0, you are in point A, and then you start moving on the line. So time 0, you are always in the point you start with. And then we can use the equation that some of you suggested. You have A, you have B, and minus A minus B for any fixed choice of A and B. This is going to be a line. Actually, in this way, you find all the lines on alpha going through point A. Okay, good. So this seems something we can do very well, very easily. Okay, so let's move to a new exercise and see how you can do that. So this is what it was called 2.2. So 2.2 says to consider the line x equal y, x equal 2y equal 3z. Okay, so this is a funny way maybe of writing a line, but what do we mean by that? Oh, thank you. Of course, well, T should be somewhere, right? Otherwise, there is no line. Thank you, Pascal Riaki. Yep. If you don't do that, it's just a point. Yep. Now look at 2.2. This is a way of writing the line. Sometimes people use it, and this means x equal 2i, 2i equal 3z, and that's defining line R because you need two equations. Or it could also be x equal 2i and x equal 3z. But you see, all these systems you can write are equivalent. So the point is, sometimes a line is given explicitly, seeing the two equations, or you have an expression like this. Sometimes people prefer the left expression simply because typographically it stays in one line, while the other one requires you to use two lines of text. That's the only reason. Okay, so we are given this line, and then we are asked to do the following thing. If possible, find a line L on pi. Pi is the following plane, x plus y plus z equal 1, such that R is orthogonal to L or R is parallel to L. So the idea is that we are given a line R, then we are given a plane pi, and we want to find a line L on pi that is orthogonal or parallel to the given line L. Okay? So let's see how you would do this. So first, try to make a visual description of what is going on, and then you try to solve it and see what you get. So say a couple of minutes to go and look, say, for L orthogonal, few minutes to see L parallel. So probably 3-4 minutes from now, and then we see what you managed to do. Okay, once you have some solutions, you can write them down in the chat so I can see. So for example, can you find these lines? If you think it's not possible, you can, just explain why you think it's not possible. You can give me your ideas of why you cannot do that. Or if you think you can, well, you do it. Okay, let's see what we have in the chat. Said Mustafa Sayedi, I don't really understand what you mean. Then MD as you fool Islam Shanto, write down y prime equal 3/4y. Actually, I have no idea what you mean. So try to do this, for example. Can you find a line R orthogonal to L lying in plane pi? Try to answer this question. Can we find a line in plane pi? So let's say plane pi is here. Then you have to have a look to line R, how it is displayed. So I make just a picture like this. Then you have to tell me, is it correct? Is it intersecting one point? And then you have to look for line L, if it exists, which is forming a pi/2 angle with that one. Okay, so Nicola Stankovic proposed a line to be orthogonal. Okay, let's see if this is working or not, right? So let's try to see. First, what do you think? Is it correct? Do we have other ideas? So let's see if you have any comment. So first, I'd like to check if my picture is accurate, okay? So what is the direction vector of line R? So let's say I want to describe the direction vector of line R to see if line R is actually intersecting, okay? So what is the direction vector of line R? So how do you find this? Well, remember, there are two ways of finding this. Either I consider, say, plane alpha, plane beta, and I go for n alpha cross n beta, and that's an option, okay? And to do that, I can say n alpha is, in the sloppy notation, 1 minus 2, 0, and beta in the sloppy notation is 0, 2, 3. Then I compute the cross product. So bear with me and see if this is correct. I get 6 minus 3, 2. So let's see if it's working. So let's try it again. The first one is minus 6, sorry. And then the other one is minus 3. Yep. So this is a possible vector P. Yeah. Here it is. And what is the direction vector? So the normal vector of plane pi, it is 1, 1, 1. So yes, they are not parallel. And so, yes, not parallel and not orthogonal, as Ali Reza Naya Fabadi suggest. Yeah. So the picture we draw it here is correct. The line is intersecting the plane, but it is not orthogonal, not parallel. It's just intersecting it nicely. Okay. So here is a probably slightly counterintuitive thing for you, because if you have plane pi and if you have a line S orthogonal, well, then all lines here, all lines going through that point will be orthogonal to the given line S. The fact is that even if you have a slanted line like R, this is something you can do, okay? Now there is quite a lot in the chat to read, so I go and read it. But the last thing is Camilla Tetti said, I didn't understand the game between n alpha and n beta. Can you explain? Well, you have to produce n alpha and n beta. They come from the equation of the planes. This is something now we need to be able to do very well. But thank you for letting me going back. You see, the equation of the first plane is, so let me write them like this, equals 0, equals 0, right? So I go and look for the normal vector. The first one is 1 minus 2. The other one is 2 minus 3. So my bad, I made a mistake in the computation. So this is a number 6. So now I have here a number 6. Then I have a number 3 here. Actually, nothing bad happens, but the computation is not correct. So thank you, Camilla Tetti, for making me go back. So this is how I produce the normal vectors, just by looking at the coefficient of x, y, z, x, y, z. And then I take these two vectors and I compute the cross product. Now, computing the cross product is something we need to be able to do very well and quickly. And the cross product computation produced vector P. Okay, and this allows me to say that we are in this configuration, not this configuration here, and luckily not the configuration of the line parallel to the plane, okay? So not this one, not this one, but the blue one is the one we are looking at. So we are lucky because we are in that situation. Okay, so now what we can do is see if, for example, there are two suggestions, one by Nicola Stankovic and one by Parnyan Satar Borugeni, about two lines, and I'd like to go and see if they are correct. Last thing in the chat, What I want to say, yes, Giancarlo Herrera, is that in this situation, it's clear you have many, many orthogonal lines to S in the plane because S is orthogonal to the plane itself. In this situation with R slanted, maybe it is not so clear if you can do that, but actually you can. And this is what we are going to do now. Now, I'd like to see the two suggestions. Let's see where I missed them. Okay. So, for example, Parnyan Satar Borugeni suggests a line with normal vector 1 minus 2. So how can I write this? So some of you suggested, let's say like this, suggestions, but we have to check. Suggested solutions. So I say suggested because we need to check them together. So one suggestion was to give the line in parametric form as x, y, z equal to, then point 1, 0, 0, and then direction vector 1, minus 2, 0. Okay, so this is one suggested solution. So first thing I need to check, is this a point of the plane? Yes, it is, right? Is this a point of plane pi? So this belongs to plane pi, so this is okay. So in this suggested solution, we have point P, 1, 0, 0, and that's a point in our plane. Then in this suggested solution, there is a vector P. Here it is, which is the vector I minus 2j, okay? And now what do we need to ask ourselves is, how is this vector with respect to the line R, or if you prefer, with respect to the direction vector of the line R. So let's let's call these PR. That's the line R we are given. Yep. So what I need to do is, what is the dot product PR dot P? And I hope you see that what you get is 6 minus 2 times 3, so you get 0. So this means that PR dot is orthogonal to P. So the suggested solution is actually okay. So this means that the line that some of you computed, this line L here, is actually a line orthogonal to R and lying inside the plane. Where is it? Oh no, we check it is orthogonal to R, yep. And now we have to check that it is lying in plane pi. So we have to ask ourselves, what happens to P dot and pi? Okay, because remember, you also want the line to be inside the plane. So it's two conditions. So what I need to compute now is with the normal vector of the plane, which is 1, 1, 1. So maybe saying ok was a little bit too much. And what you get here is a number which is different from 0. So this means that L is not inside pi, right? So the line is not inside pi because the direction vector of the line is not orthogonal to the normal vector of the plane. So this suggested solution does not work, okay? But at least it points out what we should do to make it work. Now I see something in the chat. So let me go back here. So there is something people wondering about what happens here. So that number is what we computed. How do we know if this is okay? We take the dot product of these two and we get 6 minus 6, which is 0. Dot product of this one, I get 6 minus 6, which is 0. So no correction is needed here. If you put a minus here, you forgot the rule of the cross product, which needs you to make a minus at that point. And also, if you put a minus here, it's not orthogonal to this one. Okay, so no, Eskandari, that's correct. Okay, so this is the line L suggested here is not working. And the problem is that it is not in the plane. It is orthogonal to line R, but is not lying in the plane. So what was wrong? This was okay, but we need to find a new direction vector. So what I need to do is the following thing. So I have the plane pi with its normal vector. I have the direction vector of line R, and I'm looking for direction vector of my line, and I want P to be orthogonal to n pi and P to be orthogonal to PR. So these are the two conditions we want to satisfy. Some of you, Salvatore Lagrasta says, well, why don't we take the cross product of PR and pi to do that? That's a very nice idea. That's a very nice idea. So let me write it. So now you can solve this. Or realize that P is parallel to n pi cross PR. Very nice suggestion, Salvatore Lagrasta. So you can compute as you prefer, okay? I have a slight preference now about this because it's about reinforcing in you the idea that solving linear system of equations is important, and it is what we are going to do over and over and over. So what I do is to say, I look for P, A, B, and C. So I want to find this. And so I rewrite the system as P dot 1, 1, 1, which is A plus B plus C, and must be 0. And P dot, let's go here, 6, 3, 2. 6, 3, 2, which is 6A plus 6B plus 6C. Ah, sorry. That was quick and wrong. 3B plus 2C equals 0. Okay, and so now we have to solve this system of equations. Okay, so how do we solve it? Well, you can do many different things, but this is what we are going to learn to do systematically. So the idea is to make unknowns to disappear. So why not? I can say I change equation 2 into equation 2 minus 6 equation 1. So I just keep equation 1 as it is, and I subtract 6 times it to the second one. So I get 0 times A, and then I get 3 minus 6B, and I get 2 minus 6C, which is minus 3B minus 4C equals 0. And so I need to solve the system given by these two equations now, okay? So this is what I want to do now. And what I can do is to say, well, I can play another game now to find an equivalent system to this one. And what game can I play? Well, I want to cancel b from the first equation. So I change equation 1 with equation 1 times 3 plus equation 2. So equation 2 stays the same. And I change equation 1 multiplying by 3. So we get a, and then I get 3b minus 3b, 0 times b. And then I get 3c minus 4c equals 0. And so the system we have now to solve is 3b plus 4c equals 0. And the first equation is a minus c equals 0. In other terms, the system is already solved. It is a equals c and b equal minus 4 over 3c. And so I find my solutions in this way. Okay, so let's go and leave in a look in the chat. Can we assume, for example, c equal 1? Only if c is not 0. So Nicola Stankovic, you can say c is equal 1, and then you compute. Maybe you don't find a solution because all solutions you have must have c equals 0. But then you know that you have to try to put c equals 0. So yes, Nicola Stankovic, you can do that, but then you have also to check what happens if c is equal 0. Then Albicina and Festim Kobo have some suggestion about, is it A or 3A? So let's go here and double check for a second. These are the dot products, yep. So I rewrote the equation, a plus b plus c, and then I change the last one by subtracting 6 times the first. So 6a minus a is 0a, 3b minus 6b minus 3b, 2c minus 6c minus 4c. Okay, then I just copy the second one and I use it to change the first. I multiply the first by 3. Yes, thank you very much. So let's make it in a different color. So we see it is a 3 here. Yeah, so it is a 3 here. And so it is 1 over 3 here. Thank you. Thank you. Yeah. Good, good, very well. Okay, and so let's to finish this. So for example, a choice, so vector P, any vector P working will have the shape of C over 3 minus 4 over 3C and C. So you can put, for example, C equal 1, or why not, C equal 3, and we obtain 1 minus 4, 3, and we use this to produce our line L going through the point that some of you suggested. So it was 1, 0, 0, that's fine. So x, y, z, we go through 1, 0, 0 because a point of the plane, plus t times 1 minus 4, 3. And this line now lies on the plane, and it is orthogonal to line R. Okay, Shah Ibrahim Ahmed Abdel Magoud, can you briefly explain the first suggested solution again, please? What I can say is that the suggested solution is not working, is not a solution. And the reason why it is not a solution comes from the fact that this direction vector gives me a line not on L. So the line L suggested here is orthogonal to R, but it is outside the plane. So the suggested line, let me see what I can do, is orthogonal to R. So let's draw it like this, is orthogonal to R. So goes like this. So it has a 90-degree angle with R. but it is outside the plane pi, and that's because the dot product is not 0. Okay, did we choose equal 3 arbitrarily? Yes, just to make denominator to go away. Any C will work. Now my question is, if you change C, do you get a different line or not? What do you think? If I change C, do I get a different line or not? So I have the point. So I have the point we picked, 1, 0, 0. Then I have P, which is, I call it P3. So say this is PC, okay? Comes from 3. Now, we'll change the line. And the line is spanned in this way, right? Okay, so you see, if you take any other P, so I don't know, P minus 6 or whatever, it will always be the same line. Okay, so just make a quick note. There in C, in R, L stays the same. Can we choose any C, or there are forbidden values? What do you think? Okay, 0 is forbidden. And then there is a nice question in the chat by Pascal Riaki. Pascal Riaki says, well, in this picture, the point, where is it, R? Yes, you see, R is intersecting in a very precise point, the plane. Can we choose a line not going there or not? This is a very nice question. So, in principle, lines having orthogonal direction vector, we call them orthogonal. So, even if the line we picked is not going through this point here, let's call it capital R, we are fine. However, in all the pictures we made, we want to have the line going through that point R. So what do you want to do? What do you want to change if you want to find a line L actually going through the point R? So now our question could be, what is L intersect R? Well, it is not important for the answer, so not important for the exercise. But maybe I want that my line L intersected it, and it is orthogonal. So this is the point R. So if we want to do that, so you need to find R, and then you need to change what is here with R, okay? So this is something else, something extra that if you want, you can do. So you can intersect the line and the plane and see what you get. And then you change the parametric version in such a way the line L you produce is doing that. So if you want this to happen, then you have to do something else, because in our situation, maybe we have to check, maybe this is R and this is L. They are forming the 90-degree angles, so PR and PL are orthogonal, but the lines maybe are skewed. not intersecting. So this is probably a good exercise for us to decide what is the intersection of L and R. Okay, but we have some suggestion here, because you see L intersect R is either the point R or empty. Why? Because L is inside alpha, and alpha intersect L, alpha intersect R is just the big point R. Okay, so this could be something to do, to remember, but let's do it so we also make this clear. So I want to compute the intersection of these two. How do I do this? Well, you can do in two ways. Solve 4x3 system. Remember, each line is given by two equations in three unknowns, or substitute. Let me write like this: L in R. Why? Because you see, I have a parametric description of L, right? I have a parametric description of L, and I have equations. Where are they? For R. So it's very simple for me to describe the intersection. Because what I'm going to do, I'm going to take the parametric equation, substitute, I will get a system in T. If a solution exists, is it the intersection? If no solution exists, it is not the intersection. So there is no intersection. So I do this substitution. So instead of X, I will write 1 plus T. 1 plus T, it is equal to, instead of Y, I will write, so instead of Y, I will write 0 minus 4t. So I write minus 4t. Instead of X, I write 1 plus t. And instead of Z, I write just 3t. So let's see if this is correct. Let's double check. Instead of X, I wrote 1 plus t. Yes. Instead of Y, I wrote minus 4t. Yes. Instead of Z, no, this is not possible to read. Instead of Z, I wrote 3t. Yep. Okay, so the system I want to solve is something like this. It is 1 plus t minus 8t, so 1 equal, well, let's do like this. It is 1 plus 9t equals 0, 1 plus 10t equals 0, and you will see no solution exists. So this means that L and R are skew, orthogonal, but skew. So you have to be very careful if, when you say orthogonal, you mean that they must intersect. Okay? Oh, yes, thank you. The second one is not correct. It is minus 8. Thank you. Luckily, nothing is going to change, but this is how you see there is no solution indeed. Okay, so we managed to go through these two exercises. And I think we have something also to say about, so there are 7 minutes. No, let's see. Do you have any question? Do you want anything to be done about this? Okay, so there are no special requirements. So I just remind you of something about finding the line joining 2 points, which is the exercise which is called 2.3 here. And it says, well, you have 2 points, A and B, coordinates A, B, C, A prime, B prime, C prime. So there is a unique line joining them. Well, no question about it. And well, can you find it? So say compute L. Joining A and B. Okay, well, some of you will know a formula, but that formula has denominator. So if you want to apply the formula, you must be sure to do when the denominator vanish. My suggestion is, in order to do this, that you proceed in the following way. This is the direction vector of the line, B minus A. And so you can write the line in parametric form as OA, well, don't mix notation, A minus O plus T, B minus A. In other ways, OA, if you prefer, plus AB. Okay? And you see that in this way, you will obtain at t equals 0, you are in A, and for t equal 1 time 1, you are in B. So this is one way of writing this down, which in vector notation comes to be something like this: A, B, C plus T times, what do? A prime minus A, B primes minus B, C primes minus C. So I suggest people who like the formula to find the Cartesian equation, okay, to see that what happens when you try to find the Cartesian equation from here. Okay, so I'd like you to find the Cartesian equations. Starting from this point, okay? Okay, also let me remind you that there are tutors which are there for you. All the tutors in the list are willing to give tutoring in English. So what can you do with a tutor? Well, the idea is that you go there, you have some exercise you would like to see how to solve. You try first by yourself. That's very important. You try to solve the exercise by yourself, following the lectures, following the example we did together. If you don't manage, then you can go to the tutor, or if you manage, you can go to the tutor and ask, is my solution okay? How would I, what should I do to solve this? Okay? Okay, so I cover all the material I wanted to cover. You are going to have a new lecture in a short while. I'm going to have a new lecture in a short while. So if there are no questions, I will call this a day and just say you goodbye. meet again next week and use the tutor, okay? It's important. It's giving you a good way of learning. So don't forget about the tutors. Use that service too. Okay, bye-bye.